Okay, so we have spent a lot of time on inscribed angles, and there are some other special angles in the circles that we need to talk about as well. So, uh, the thing I want you to focus on is when you're looking at the angle, where does the angle show up on the circle? So it's either going to be on the circle, inside the circle, or outside. We already did inscribed, and so our property actually works here. If it's on the circle, we already know, that's inscribed. So that property fits. So on the circle, inscribed, the vertex of the angle is on the circle. The other kind that we will see like this are on the circle kind of at an angle. And this is called a secant, and this is called a tangent. A tangent means touching at one point. Secant means touching at two. But essentially, if these are on the circle, then they're half of the arc that we go through. So you can trace your angle like we do. And so that angle question mark there is half of the arc. So half of 90. So that would be 45. Sometimes it's not as direct. So this one still is on the circle. And so the angle is 59. It would be half of the arc. So that means this arc is 2 times this angle. So in this case, that's 118. On this problem, it's actually asking for the rest of the circle. So to get to your answer, you could take 360 minus 118, but mainly wanting you to understand that this is 118 right now. Okay, so that's on the circle. It works for inscribed angles, and it works for these secant. These are called secant tangent angles. It's the fancy name. Okay, inside would be the next place, and inside, your keyword there is we take the average. Now, these formulas on your formula sheet, you don't have to memorize them. I think it helps to understand, though. So this happens whenever we have kind of an X going on here. Okay, and so the angle we're trying to find is on the interior of the circle, and those are actually both secants, or both chords, you could say, but that are intersecting. And so the formula is this angle question mark here is 1/2 the sum of the two arcs, which also means you're taking the average of the two arcs. That's why my short term for this is the average. So it's the sum of the two arcs. So the arc we're going through here is 110, and the arc we're going through here is 50. So half of 110 plus 50 is 80. So that angle right there is 80. The one that always tricks people then is when, just like anything else, when you don't have the direct 2 that you need to work backwards from it. And so I'm working backwards here. I'm still going to trace. And my formula is the angle is half of the two arcs added together. So if you always start with your formula, then you know the angle, well, they give us the angle this time, is half of the two arcs. So this is what the one we're trying to find. You can call it X or you can call it question mark. Here's the key step now. I have to solve this equation, and I have to use algebra rules. I can't just start dividing and multiplying and subtracting and order of operations. I have to get rid of this half before I can do anything with this 75. So to do that, you multiply by 2. Because 2.5 cancels out, just leaves me with 75 plus question mark. And then 2 times 77 is 154. Now, some people memorize that. I would say if you want to memorize something, say memorize to get rid of a half, you multiply by 2. Now you can just subtract and solve. So you get 79, I think, when you subtract that. So when you're looking at this problem, if you want to check, at the very end, it's the average. Does 75 and 79, when you take the average of those, do you get 77? Well, 77 is right in the middle. That's what the average is. It's in the arithmetic middle. So 75 is 2 less than 77. 79 is 2 more than your average amount. You get that value. Okay, so that's inside. So we had on the circle, inside the circle, and now we have angles that are outside the circle, and there's 3 different kinds here. They all have the same formula, though. So as long as the thing is outside the circle, you're good. Okay? And I call it half the diff because we're taking, if you notice, we're taking half of the difference of the arcs that are intercepted. So let's do the first one here. So I highlight my angle. And now to find that angle, I'm going to take half the difference of this arc and 115. So my angle is half the difference of arc MK, whatever that is, and 115. So to find MK, I can take 360 minus 115. That's 245. So my angle is 1/2 245 minus 115. Half of 130, 65. Now, one thing you will notice, this is called a tangent-tangent angle. Something that's true that some people remember the shortcut, some don't. With a tangent-tangent angle, the outside angle and the arc always add up to 180, just because of the way this formula always works out. So if you had a tangent-tangent and this was not a very good one, looks like a little clown. If you had a arc there that was 100, then this angle outside would be 80. Okay, so another one would be a secant and a tangent. So again, half of the difference. So the angle is half the difference between the big arc and the little arc. So 149 minus 59. In this case, they gave you both arcs. So 149 minus 59 is 90. So half of 90 is 45. So those are kind of some straightforward examples on inside, outside. On the back of this paper, you have more examples and the answers to go with them. So you can start working on those. I want to do one more outside. I'm going to show you what number 9. So there's my 2 arcs and my angle outside. The angle is half the difference between the big arc and the little arc. Okay, so what I'm going to suggest that you do on this problem, the answers are over here. I would suggest you do is go through and write on inside or outside on all these problems first before you do them. So number 1, you're like, that's on the circle. And then I know what formula. That's inside. And when I help you in class, I'm going to ask you to tell me on inside or outside, because if you know that, you know which formula to go to. Okay? If you look on, and you may want to look on your formula sheet as well, if I have a copy sitting here. And so you know where to locate these formulas. With everything but that on my desk. You can locate those formulas as well. Okay?